So after thinking through this, I really like this offset effect from that previous screen, but I didn't like rotating the orbits a degree because that threw the accuracy off. So in this spreadsheet, they actually show, if you go over here far enough, they show the launch date. And so using a simple Excel function, I just calculated the age of the satellite and kind of got a feel for the range. So they go from, the earliest one on this list launched in '74, and they obviously come down to being a year old. So with that in mind, I kind of looked at how many were in each category, and I decided to come up with this scaling chart. So far there's one that's unknown. It didn't have a launch date, so I just put that there. But anything that's 0 to 2 years old, I've assigned a width of 0.5 centimeters with 100% opacity. If it's 3 to 5 years old, it gets a width of 1 centimeter with a 65% opacity. 6 to 10, 2 centimeters wide, 50% opacity. 11 to 15, 4 centimeters wide, 35% opacity. 16 to 20, 8 centimeters wide, 20% opacity. 21, 25 years, 12 centimeters wide, 15% opacity, and then this 26 plus, there weren't many, but it's 16 wide with a 5% opacity. And started to apply that on these layers. So I love the way this looks. It's really starting to, it gets us away from the problem, which was previously all the satellites were this size. They were just 0.1 centimeter. So they were very tiny. They're right there. By doing this now, we've taken a layer which was just a bunch of small dots, and we've given a visual representation of kind of how old all this space equipment is, which is kind of driven now, kind of unveiled the purpose of this infographic, is we're getting beyond just the orbiting aspect, and now I'm really curious to kind of look at, hey, how old is all this space stuff, and when is it just going to be useless space junk? Because as you look here, you see the expected lifetime. A lot of these are, 2 years. This one only had an expected lifetime of 4 years, and it's 14 years old. So, it starts to open up this aspect of, hey, how fast is the space equipment aging? Are we going to have a massive, space junk crisis on our hands? And we'll see what happens there. So I'll just kind of activate some of these layers as we go. And you can see it's much more visually compelling than just a bunch of tiny dots, and even way more compelling than when we turned on the orange layers. And as you begin to zoom back, hey, we're out here. Where's the medium Earth? There's the medium. Here's the geostationary. So we're kind of getting farther away, even at the 100,000 kilometer. There's still some interesting things going on. So this thing's starting to meet my criteria for a good piece of data art, which is, again, that it looks great at all levels of detail. So when you're all the way out and as you get in closer, it looks fantastic. So it's starting to come together. You'll notice that I hid the orbits. With the orbits in play for each one of these, there was just a big black dark ring, and I thought, well, that's really not important because the satellites themselves make most of those orbits. But what I did do is any sort of orbit that was obviously kind of oval shaped, I kept those visible, which I think adds just a ton of intrigue when you get out here and you see these orbits, they're really out here pushing the 100,000 kilometer boundary. And as we progress, there's even a couple orbits that extend beyond that 100,000 mile boundary, which I think we're going to get into a scaling issue with one. But that being said, this is how I decided. This is how I landed on visually showing these. So that's where it's at now. I'm going to keep building, and we'll come back sometime later.